Hey everyone, if you're working with NVIDIA BlueField DPUs, chances are you've run into this one. That super frustrating moment at startup when the IPMB host driver just fails to load. You've probably stared at that error message wondering what to do next. Well, you're in the right place, because today we're going to walk through, step by step, exactly how to fix it for good. Let's jump right in.
So here's our game plan. First, we'll break down the actual problem with the IPMB driver. Then we'll get into the most common fix, which is sorting out I2C address conflicts. After that, we'll set up remote IPMI access, lock things down with some security hardening, talk about CentOS integration, and then wrap it all up with a final checklist to make sure everything's running smoothly.
So, does this look painfully familiar? You boot up your shiny BlueField DPU, you check the logs, and there it is. The IPMB host driver just refuses to register. It is an absolute showstopper, right? Especially when you need that management interface to get your work done. But don't worry, we are about to make this error a thing of the past.
Okay, before we dive into the fix, let's get on the same page. We're talking about the IPMB, or the Intelligent Platform Management Bus. The easiest way to think about it is like a private, dedicated communication highway inside your system. It's the road that lets the DPU's ARM brain talk to the main baseboard management controller, or BMC. When there's a traffic jam on this highway, nothing gets through.
All right, let's get into Section 1, the IPMB driver problem. To really solve this, we've got to understand what's actually breaking under the hood.
So to really get this, you have to know there are two main characters in this story. We've got two drivers. The first is IPMB dev int, and its job is to let the BMC send messages to the DPU. And then we have IPMB host. That's our troublemaker, and it lets the DPU talk back to the BMC. See? It's a two-way conversation, and we absolutely need both sides to be working.
And here it is. The root cause, like 9 times out of 10, is a simple I2C address conflict. It's kind of like if two houses on the same street had the exact same street number. The Postal Service would have no idea where to deliver the mail. Well, in our world, the system gets just as confused and just gives up, which is why the driver fails to load.
So let's move on to Section 2 and actually get our hands dirty. We're going to go in and fix that address conflict once and for all. If you take a look at this table, you can see how the default setup works. You've got 4 different I2C addresses, and which one gets used depends on who's talking and who's listening. You've got addresses for when the BlueField starts the conversation and different ones for when the BMC does. The main takeaway here? Every single one of these addresses must be unique.
And this right here, this is the golden rule. It's not a friendly suggestion, it's a hard requirement. If any of those addresses overlap, you are guaranteed to see one of the drivers fail to register. This is the absolute core of the problem we're fixing today.
Now for the good news. You don't have to go on a wild goose chase looking for these settings. Everything we need is located in one convenient place, a script file called set_muparam.sh. That's our target. So once you open up that script, you're going to see these 3 key parameters. You've got IPMB dev int add and IPMB host add, which, you guessed it, set the addresses for the BlueField's 2 drivers. Your job is to make sure these 2 values are unique. Then there's IPMB host client address, which tells the BlueField what address the BMC is listening on. Just check these against your BMC settings, make sure nothing clashes, and you should be good to go.
Awesome. So with our driver loading properly, let's move on to the really cool stuff. Section 3 is all about enabling remote access. This is how you manage your DPU out of band. And trust me, it's a game changer.
Setting this up is super easy. Just 3 simple steps. 1, you're going to open up the progconf file. 2, find the OOB IP variable and plug in the static IP address you want to use for out-of-band management. And 3, just restart the MLX IPMID service to make the changes stick. And that's it. Now you can manage your system over the network.
Okay, we've got remote access working, which means it's the perfect time to talk security. Welcome to Section 4, Hardening I2C Security. We need to make sure this powerful management interface can't be turned against us.
So here's the scenario we want to avoid. If, for some reason, the BlueField's ARM processor gets compromised, an attacker could potentially use it to jump over and get total control of the BMC. To slam that door shut, the best practice is to disable the I2C1 channel. That's the specific path from the ARM to the BMC.
And you've got 2 great ways to do this. If you're all about automation and scripting, the Redfish API method is going to be your best friend.
But if you'd rather use a graphical interface and click through some menus, you can do the exact same thing right from the UEFI BIOS during boot. Let's look at both. Using Redfish is pretty slick. You just send a patch request using a simple curl command that sets the Disable I2C1 flag to true. Then you can run a GET request just to make sure the change was saved. After a quick reboot, you can pop into the command line and check the /sys/bus/I2C/devices directory. If you don't see I2C1 listed anymore, you're golden.
Now, the UEFI way is just as effective. You just restart, hop into the BIOS, and navigate your way to the device manager, then into system configuration. You'll see an option that says Disable I2C1. Just check that box. Save and exit, let the system reboot, and then do that same final check. Make sure I2C1 has disappeared from your device list.
Okay, let's switch gears and talk about the software environment. Section 5 covers the nitty-gritty of system integration, and we're going to focus specifically on what you need to do if you're running CentOS.
For any of this IPMI magic to work on CentOS, you have to make sure the right kernel modules are loaded. Think of these as the essential building blocks. Without them, the system just doesn't know how to speak the language of IPMI. So make sure all of these are present and loaded.
So the whole integration process follows this flow. First, you're going to build the RPM packages for OpenIPMI and our two drivers, IPMB DevInt and IPMB host. After they're built, you install all three of them using Yum. And the final piece of the puzzle is to enable and start the services that actually bring everything to life.
And here we are at the home stretch. We've done all the hard work, and now it's time for the moment of truth. Section 6 is our final validation checklist to make sure we got it right. If you're still seeing problems, just run down this list. First things first, is the BMC even turned on and responding? You'd be surprised how often that's the issue. Second, go back and triple-check those I2C addresses in setmuparam.sh. Are they absolutely, positively unique? Third, did all the kernel modules actually load? Fourth, are you sure the RPM's installed correctly? And last but not least, check the status of the MLX IPMod service. This checklist will catch almost any issue you might have. And there you have it. Your IPMB driver should now be loading perfectly, giving you a stable and, more importantly, a secure remote management interface. This really opens up a whole new world of automation and control. So that leaves just one question. Now that you have all this power, what are you going to automate first? Thanks for tuning in.